The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba Caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast.
These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano, so that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news. On January 14, 2022, residents of Anchorage, Alaska heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research models showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions. Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again.
The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvius, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project, named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
Alert! Alert! Leave all your things behind and find safety immediately. The southern continent has just erupted. This is not a drill. You see people running around, screaming their heads out. Cars bumping into each other. The whole nation is in panic. You're on the southern coast of Australia, but the sky is black and it stretches further than your eye can see. Your friend in southern India calls you and says the same thing. There's ash in the sky and it's raining down on you. You hear rumbling in the distance, and it isn't even your stomach to blame. Everyone starts running inland. The black clouds swallow up everything in sight. Cars, trees, buildings. You're unable to see anything in front of you. Everyone's confused and scared. A tsunami breaches the shores, covering everything in its path. This is the Great Antarctic Eruption. Antarctica is that big continental desert covered in ice. In fact, it's technically the largest desert in the world. It's also covered with a whole lot of volcanoes, just chilling around. Scientists discovered that there are 138 volcanoes in Antarctica, 91 of which are hidden beneath the icy surface, and 47 on top. And there might even be more. But most of these volcanoes are dormant. And for a volcano to be dormant, it has to be fast asleep for the last 50,000 years. The last volcano eruption was Mount Erebus in the western part of the continent. It's the most active volcano in the south side of the world and is roughly 12,500 feet above sea level. That's as high as stacking the Burj Khalifa on top of itself 5 times. There's a whole bunch of these volcanoes stretched across the entire continent. In the most concentrated region, the volcanoes spread the distance equivalent to that between Canada and Mexico. And that's not even all of them. Scientists have warned that if any of these interior ice-contained volcanoes were to erupt, they'd melt the western Antarctic part of the land and increase the spill of ice into the ocean. It would raise the sea level and flood many endangered lands that are already at risk. And that's not mentioning the tectonic plates shifting underneath the surface, which allows some of the magma to squeeze its way to some surfaces. It's scary enough to expect what would happen if a huge volcano erupted. But what would happen if all the volcanoes in the Antarctic continent erupted at the same time? If you were one of those scientists on a boat on their way to conduct some experiments, you would begin to feel unease. you'd notice the water carrying a bit more of the current than usual. You look at your fellow scientists, and they too have the same look on their faces. As you land at the shore and take out all your tools and equipment, things don't seem normal. But the work has to be done. You head to the base and settle in. Business as usual. In the barren land, you see some emperor penguins waddling around, hunting, playing, and doing penguin stuff. But as you look around, you notice that the penguins all suddenly head to the ocean, and many of the wild Antarctic birds also begin flying towards the horizon. Weird. Then the ground starts shaking, and behind you appears a tower of smoke reaching to the sky. The ashes from a volcano can be very harmful for anyone with lung conditions, and even healthy people. The gases that come with it are usually blown away quickly, but are also harmful to humans and cause irritation to the eyes and throat. But if you're nearby, you may need a gas mask, or better yet, evacuate! The gases and ashes are the most dangerous part of a volcanic eruption. Even though the lava spewing and explosion may seem scary, the smoke in the sky can spread far away and even halt planes flying around. You look to your fellow scientists, and they signal to you that it's time to go. Make like the penguins and swim off. But the waters are extremely rough, and the rumblings getting louder and louder. Suddenly, you see more smoke wafting towards the sky, but from different locations. Back to the boat! It's sad to say, but leaving all that equipment was needed to survive. Carrying all that stuff would have slowed you down. But you're safe. For now. Looking behind you, you see a dark smoke screen covering every corner of the continent. Volcanoes have different types of eruptions. It's not just the shooting out lava into the sky scenario. They can range from aggressive to calm. Some spew out lava and some don't. This all depends on the environment, the number of gases contained, or if there's any groundwater present, and even the chemistry of the magma. So, chances are you'd be seeing all various types of explosions around you. You're out of Antarctica's mainland, but it's surrounded by lagoons and giant ice caps all around. You're doing your best to maneuver around them. But the ash is falling down all around. The sky is dark as the smoke blocks out the sun. Volcanic ash comes in all sizes and can cause different damage, from as little as lung and eye irritation to smothering vegetation and crops. And that's just the thing. More often than not, these volcanic ashes are extremely thick. They can even collapse the roofing of some buildings if a lot of ash is accumulated. Not to mention blocking roads and compromising aquatic life. And that flash in the sky isn't your imagination. Ash clouds in the sky are so powerful that they create electrical fields that can create lightning storms. And these bad boys can interfere with radio signals and even start fires. Also, these clouds are extremely hot on their own. As if that lava flow isn't enough to start any fires. Oh well. But there are some volcanoes that are explosive, and along with the ashes flying around, there are flying rocks. This overheated rubble comes striking down like meteoroids from the sky, and can be pretty dangerous. You see the rocks hit the surrounding ice caps and water around you. As you reach a somewhat safe zone, you see the volcanoes all nicely lined up behind you, spewing all that thick red gooey fire. But the water tide isn't exactly peaceful. Volcanoes near oceans and seas can even cause tsunamis. Great. Submarine earthquakes shake the ocean bottom and produce large, powerful waves. And don't even think about surfing on them. If there are volcanoes spitting out red-hot lava, then why hasn't all the ice in Antarctica melted? The answer lies beneath the Earth's surface. Tectonic plates barely move underneath there. It's pretty safe to say they're stable. So for such a large piece of land, the coldest continent on Earth, the few active volcanoes are insufficient to melt all the ice. The real reason why the ice is melting and water levels are rising is the warm ocean current around Antarctica. But this time, they're all erupting at the same time. With the volcanoes discovered, who knows how many are left underground, covered in ice. And that's the scary part. Some of these volcanoes are hidden so deep beneath the icy surface that they now heat up from the lava spewing out. The ice begins to destabilize everything around. The ice on the ridges begins cracking open little by little. Like giant cans of soda bursting open, lava shoots from the snowy depths, causing enormous cracks in the ground. And then, magma finds its way to the party. This uninvited guest will begin to melt the surroundings, causing the ground to destabilize even more. Slowly but surely, the ice around Antarctica will melt. And if all the ice is melted, the Earth's sea level would rise by around 230 feet. That means coastal cities would be submerged underwater. The ocean currents would be flipped around, and hurricanes and typhoons would not want to take a break. Marine life would be in danger, and many small islands would completely disappear. And not to mention the smoke in the air that would travel around the world, halting many flights in the southern region. And if the winds were strong enough, the whole world. The economies would flop, and a worldwide panic would begin. Health emergencies all year round. Yeah, a real nice picture.
Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt, and one day it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet, all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over. but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. Plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic, smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Ah, Kiev. You've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast. In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are, with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sun dogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's Altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water. The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear. And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tektites. Tektites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tektites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tektites were too widespread. That's why they couldn't pinpoint the exact location. Until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tektites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, One pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Mauna Loa Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot-wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high, they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone Supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other super eruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass.
How do you prepare for a long trip? You probably look up the route on Google Maps or watch a walkthrough on YouTube. Or maybe you ask someone who's been there recently. But what if you're bound for a place humans have never existed? Yes, I'm talking about our next-door neighbor, the Red Planet. NASA is planning a mission to Mars in the late 2030s or early 2040s. That's too far in the future. So why start preparing now? Well, it's closer than you think. Rookie astronauts spend at least 2 years training just to go out in space. For every hour they spend in space, they need to spend 10 hours underwater on Earth. This training only applies to spacewalks and the International Space Station. So far, some 600 people have been to space, but humans have never set foot on Mars. Traveling to this planet will require a different kind of training. Is there a region of Earth that closely resembles Mars? The Apollo mission's astronauts trained in Nevada. This is where Neil Armstrong and his fellow astronauts got a sense of what the surface of the moon would feel like. But Mars is different from the moon. It has gravity and an atmosphere. In this aspect, it resembles our own planet. Just one country, to be more precise: Iceland. NASA used this island in the far north of Europe as a testing ground for its 2020 Mars mission. And no, the mission didn't involve humans landing on the red planet. Just a small rover looking for signs of life. But the high-tech robot still needs some practice. Let's do a little test of our own. Compare the landscapes on Mars and Iceland. Are you struggling to spot the difference? Good. That means that scientists have picked the ideal training grounds for the upcoming Mars mission. An area entirely barren and devoid of life. That's how one researcher involved in the mission described Iceland. And this description perfectly matches the conditions future astronauts will encounter on Mars. But what's so special about Iceland? There are valleys that were created by volcanic eruptions. The island is still young in geological terms. Simply put, it's still forming. Lava flows, water, volcanoes, raging winds. Iceland has it all. The country's slogan is the land of fire and ice. The island's population is just above 350,000. For comparison, the city of Cleveland in Ohio has more residents than the entire country of Iceland. But the size doesn't always matter. Remember Euro 2016? When England lost to Iceland 2-1, their players became stars overnight, but Icelanders are closer to the stars than you think. The country has a space agency. Yeah, you heard it correctly. Now, this agency actually consists of 2 people who are trying to promote Iceland as a terrestrial analog to Mars. In short, this means that Iceland looks a lot like the red planet. The local duo wants to get space scientists to choose Iceland as a training ground for future astronauts. Their biggest argument is that it's cheaper. Sending people and equipment into space is expensive. Duh! According to Elon Musk, SpaceX launches cost around $2 million. That's way less than a typical NASA launch. A large portion of space research takes place back on Earth. Antarctica is ideal for studying cold and desolate places in outer space. Hawaii is perfect for exploring lava tubes and the composition of rocks. Just imagine the logistics behind going to both of these regions at the same time. This is where Iceland comes into play. It has diverse habitats that are relatively close to each other. So what exactly will future Mars-bound astronauts do in Iceland? To answer this question, let's travel back in time. Nevada wasn't the only place NASA's astronauts visited more than half a century ago. They prepared for walking on the surface of the moon in Iceland too. Their primary objective was collecting rock samples. These can mainly be found near volcanoes and lava fields, and Iceland has plenty of those. Around 60% of the local landscape is rocky and rugged. This makes the island the size of Kentucky feel like another planet. Add that to the fact that 80% of Iceland is uninhabited, and you get the perfect playground for astronauts. And there's another similarity with Mars. In summer, it can seem as if the sun never sets in Iceland. Locals go shopping at 3 a.m. In June, for example, the night can last only 2 hours. Sounds like a perfect open-air party destination. Well, not really. Who would want to party at a freezing temperature of 42 degrees Fahrenheit? That's the average low air temperature in June. Future astronauts spent weeks in Iceland, trying to adjust to these strange conditions. This helps them prepare for the long days on Mars. This is not a figure of speech, since days on the red planet are longer than the ones on Earth by 40 minutes. That's not much, considering the length of days on other planets. On Jupiter, a day is over in just under 10 hours, while a day on Venus equals 243 Earth days. But let's first land on Mars and then think of other planets, shall we? Have you been doing some math in your head? If one day on Mars is 40 minutes longer than on Earth, then how long is a Martian year? Nope, I'm willing to bet your calculations aren't correct. You forgot to factor in an important detail. The planet is farther from the Sun than Earth. This means that a year on Mars lasts 687 days, nearly twice as long as a year on Earth. Sorry, future astronauts, you'll get a birthday cake once every 2 years. There's another minus to the red planet, literally. The planet's average temperature is minus 76 degrees Fahrenheit. Makes Iceland's climate feel like the tropics, huh? Despite these extreme weather conditions, scientists believe that water once flowed on Mars. And where there's water, there's life. That's why NASA scientists lowered the tiny rover in the middle of a crater that they suspected was once a lake. This is where it stands the greatest chance of finding evidence of life. What about life forms on Mars? Looks like it's not science fiction. The planet has polar caps like Earth, and that's not all. Scientists believe they've even detected snowfall on Mars. Its atmosphere is 100 times thinner than that of our planet. It isn't a breath of fresh air, but it isn't extremely inhospitable like other planets. On Venus, it rains acid, and the temperature is high enough to melt lead. And on Jupiter, there are gigantic storms that rage on for centuries. Makes you fall in love with the blue planet all over again. Even Iceland sounds fun at this point. You might even want to learn Icelandic. If you're successful, then you can even read Old Norse, the language of the Vikings. And you'll know 100 words for wind. This will come in handy as wind speeds on the island can reach up to 40 miles per hour. Out in the open, you have to hold on to a fence or a signpost to stay on your feet. Iceland's climate will make you think twice before moving there. But for astronauts preparing for another world, this place is perfect. Iceland is equally impressive underground. In fact, the island might hold the key to sustaining human life on Mars. The surface of this planet is not very hospitable. The soil is poisonous and abrasive. It can easily cut through an astronaut's suit. But underneath the ground, the living conditions are more tolerable. And Iceland has a real-life model of this potential underground dwelling: lava tubes. Long tunnels carved out by lava making its way to the surface. These maze-like corridors are perfect human habitats. And they're cost-efficient. Nature had already built them for us. Future astronauts can walk through similar lava tubes in Iceland. Who knows? One day, their cautious steps might turn into giant leaps for mankind.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed and bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean, but it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2 million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists. Gwajan Volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantire Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believed the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood Falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles, and become the third on the list of the longest track tornadoes in New England. In the Philippines, you can swim in some of the most crystal-clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a Sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Davasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean, with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of super hot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenadoes can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity. A human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color, and since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shibam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agung, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long, long nap. In 2021, scientists were sure it would happen soon. But so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma, so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Eri Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helens slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress is accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up, because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads-up about volcanic eruptions years before they happen. With this new, weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaro, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in a rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the Earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleysite and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster, destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature